Good evening, Niharika.
Yes, sir.
So here, as we'll be starting with capacitor, then we'll move on to some questions from current electricity. You have a parallel plate capacitor with air between the plate, has a capacitance of 15 microfarad. Okay, before I start over here, there are certain questions. What topic the questions are generally based off from the capacitance? You will be getting the questions based on increase or decrease in voltage when a dielectric is inserted between the plates. You will get questions based on increase or decrease in capacitance. Again, on the same concept. Increase or decrease of capacitance when the distance between the plates is increased or decreased, that is half or double. You'll also get questions from energy based. So energy concept questions will be there. Loss of energy. Loss of energy is an important concept from the uh, capacitors. So before going to your exam, you must revise these topics. You must be revising about energy of the capacitor. You must be revising about the change in capacitance and change in potential. Change in capacitance and potential. Okay, so these are three important topics. You are most likely to find out one or two questions from this topic. At least loss of energy, that means from the energy, loss of energy is an important. Let's see the first question. Let's see. A parallel plate capacitor with air between the plates has a capacitance 15 picofarad. The separation between the plate becomes twice and the space between them is filled with the medium of dielectric constant 3.5. Then the capacitance becomes x by 4 picofarad. So the value of x is. So the same question as I discussed, that you will be getting the question what will happen if the space between them is increased or decreased, if the space between them is filled with the dielectric. So this is a combination, a similar question. So the two things, as you know, the capacitance of a parallel pressed capacitor is given by A epsilon naught by D. So here we observe that capacitance is proportional to the distance. Also, we know that capacitance or new capacitance is equal to K times of C naught, where C naught is the capacitance, original capacitance means the capacitance when there is no material between them. That is when you have air between them, that is the capacitance. So first of all, let us find the value of C. Let us see the original capacitance is 15 and what will happen if the distance is, the separation between the plates becomes twice. So if the separation becomes twice, if this D becomes double, so what will be the new capacitance here? Yes, the distance is doubled. So capacitance is inversely proportional to distance. So what should be the new capacitance here? Should this capacitance is 15 ohm, 15 picofarad. And if you are doubling the distance becomes twice. So this new capacitance would become 15 by 2. That's half of it. Okay. So this new capacitance will be half of this because the distance has doubled and we know that the capacitance is inversely proportional to the distance. So this is the new capacitance. Now coming to the next part here, and the space between them is filled with a medium of dielectric constant 3.5. So now the new capacitance C times C dash will become 3.5 times of this capacitance, that is 15 by 2. We can write this 3.5 as 7 by 2. So I can write it 7 by 2 multiply 15 by 2. Now can you tell the answer what would be X? Yes, Niharika, what will be the value of X here? Niharika?
Yes,
If you compare both of them, so you are getting here 105 by 4. So the value of x is 105. 15/7 times or is 105. So you have 105 by 4, and hence the value of x is 105. So the question just rotates around these concepts. This capacitance and the dielectric constant. You will also have the dielectrics, two dielectrics filled between them. We'll see. So let us see another one. A parallel plate capacitor has plate area 40 centimeters square. It has a plate area 40 centimeters square and the plates separation 2 meters. The space between the plates is filled with the dielectric medium of a thickness 1 mm and the dielectric constant 5. The capacitance of the system is. Okay. So this question is now a little bit more depth. More depth means here the complete space between the dielectric is not a complete space between the plates is not dielectric. Only a portion of it is filled with the dielectric. So for this, you have a question here. You have typed. We know that the capacitance of any capacitor C is given by A epsilon naught by D. This is the formula for capacitance of any capacitor. Okay. Now, if suppose within this capacitor, let's say the capacitor has the thickness D, and in this thickness D, you have another plate inserted. You have a plate inserted between them. So here you have a plate. Let's say the plate has the thickness T. So you have a plate of thickness T inserted between them. And this is the question of this variety. So you have a plate of thickness T which is inserted. You want to find out the new capacity. So anyone who remembers the formula for this new capacitance? Formula of new capacitance. When you have a capacitor inserted, when you have a dielectric inserted between the two. So here the formula is something like this. You have the new capacitance C dash is given by A epsilon naught over D minus uh, T times of K. So from here, you can take out your D common. You can take out your D common. So you'll get here A epsilon naught by D. And here you will have 1 minus T by D multiplied by K. So in this way, we have some value being decreasing from 1, and hence you will have a new dielectric. So this capacitance will be A epsilon. We are given all the values. You can put the values of area, D, T and D. The value of T is just 1 mm. The value of D or thickness is 2 mm. You put here 2. That becomes 1 by 2 multiplied with the dielectric constant. So the dielectric constant is 5. I think T1 minus T plus T. Okay. Oh, just one incorrect. You need to make some correction here. You have K here in the numerator. Here you have the K. That comes K. Now this is the formula. You can use this formula to find out the new capacity. Just put the values everywhere. You will get the answer of the new value of the capacity. So I hope you can solve this out and check the answer. You need not convert your meter and centimeter. Yeah, centimeter square, which is given as area, it needs to be converted to meter square. And this D, it needs to be converted again. And you can find out the answer. So K is 5 multiply area. Area is 40 centimeters square. So you have 40 multiplied 10 to the power minus 4 meter square divided by D, which is 2 mm. So you have 2 multiplied 10 to the power minus 3. And epsilon naught, you have to keep your epsilon naught here, divided by 1 minus T by D. So T by D is 1 by 2. So 10 to the power minus 3 goes here. You have 10 to the power minus 1. And you have 10 to the power minus 1 vanishes with this 0. Then you have 2 and 2, right? You get here 10 epsilon naught over 2 minus 1 is 1. So 2 minus 1, 1 and by 2. 1 by 2. So you are getting somewhere 10 by 1 by 2. That should be 20. Okay, I'll check it once more. I'll check out this question. Okay, we should be getting here answer 20 epsilon. So I'll check out this. You can try it out. Let's see the next one. A capacitor has capacitance 5 microfarad when its parallel plates are separated by air medium of thickness D. A slab of material dielectric constant 1.5 having area equal to that of the plate but thickness D by 2 is inserted between the plates. The capacitance of the capacitor in the presence of the slab will be. So this also, this you can try out. This is the similar question which we did just now. So similar one, you can try the same. The same formula will work here. The plate area is same, but it's just the new thickness is D by 2. Yes. Now this one, the next question is based on the loss of energy. A capacitor of capacitance 900 microfarad is charged by a 100-volt battery. The capacitor is disconnected from the battery and connected to another uncharged identical capacitor such that one plate of the uncharged capacitor connected to the positive plate and another plate of uncharged capacitor connected to the negative plate of the charged capacitor. The loss of energy in this process is measured as. So I will tell you one simple formula also to find out how the loss of energy can be computed. So let's see. You have the capacitor which was 900 microfarad. It's charged by a battery of 100 volts. So battery B is given as 100 volts. And you want to, the capacitor is disconnected from the battery and connected to another such identical capacitor. So here in this case, the energy of the capacitor, will be given by 1 by 2 CV squared. This will be the energy. So you can get this 1 by 2 multiply C, which is 900, multiply V square, which is 100 square. And of course, you have a micro here, just a micro. So it is 9 by 2 multiply, here you have 10 to the power 4 and 2, 6. So micro and all cancel. You have 4.5 joule of energy. That is the energy present with this capacitor. Now, when this capacitor is connected to another capacitor, so this capacitor is connected like this to another capacitor, something like. So this first capacitor initially it has the voltage V. Its voltage was given was 100. Now, since the charges started flowing from this capacitor to this capacitor, so it will lead to the discharging of the first capacitor and charging of the second capacitor, and hence a decrease of voltage of this first one and an increase of voltage in the second one. Now, the common potential, since the two capacitors they are identical, you will get the common potential here. Common potential would be 50 volts. So now they have a common potential of 50 volt, and they what should be the new capacitance here? What combination shall we look for? Are they connected in series or are they connected in parallel? The capacitors here, they are connected in parallel. You can find out their new equivalent capacitance will be equal to C1 plus C2. That makes 900 plus 900, 1800 microfarad. This is the new capacitance, and hence we can find out the new energy. The new energy would be equal to again 1 by 2 CV squared. The new capacitance is 1800, so you get 1 by 2 times 1800 and times V squared, which is 50 squared. So you'll get here 900 multiply 2500, or this is micro. If you multiply it by 4 and divide by 4, so you'll get 25 times 4 is 100. So 100 means 10 to the power 2, 10 to the power 4 and 10 to the power 2. It makes 6. So you will get here 9 by 4, and 9 by 4, here the original energy you had 4.5, and now the new energy that is available is just 9 by 4. So can you obtain the loss of energy here by subtracting both of them? If you make this 9 by 2 minus 9 by 4, you get the loss of energy. Javian?
Yes, sir.
Yeah. Okay. So can you obtain the loss of energy? Have we gone somewhere wrong in the place? Or I think here finally the energy should be coming as 10 to the power minus 2. So just check for once more, check for the calculations. So check for the calculations. I think here it should be 2500 times 900. Just one. And check your calculation here, 2500 times 900. It is coming 2.25 multiply 10 to the power 6. Yes, you are getting 2.25 multiplied 10 to the power 6. That is 10 to 2.25. We are correct. So why they have given 10 to the power minus 2? If they give it 10 to the power minus 2, so obtaining the loss of energy here, it should be 4.5 minus 2.25, you get 2.25 as the energy. Now, if you write here 10 to the power minus 2, so the value of x should be 225. Since I checked out, our calculations are correct. So the value of x comes out to be 225. That is the loss of energy that is achieved during this process. Now, what we want to know here, that in this question, it was simple that both the capacitors, they had the same capacitance. If what would happen if the capacitors have a different capacitance? Suppose the capacitors, they have a different capacitance. So then we need to find out the common potential. So here the common potential. Let us see, try to find out the, or let's say, you can find out the common potential also if the two capacitors are different. So let's say here we have this capacitor as C1 and this capacitor as C2. So now the two capacitors, they are not with uh, the two capacitors, they do not have the same voltage. They do not have the same potentials. So capacitance is also not the same. So when the discharging takes place, there will not be. Hello, hello. Uh, uh, निकल गेल पैसा पैसा निकल गेल बा 2000 निकल गेल बा हाँ कट गेल बा भाई हाँ पर्ची नहीं भाई एक बार फेल्ड हो गया एक बार सक्सेस बता रहा है Okay, Javier. Thank you for waiting. See, we had to see here, we want to find out the common potential. Let us say the capacitor C1. Now I'm making your situations complex. So the capacitor C1, it was charged to the potential V1 and the capacitor C2 was charged to the potential V2. Now if I want to find out the common potential V, so the common potential V after connecting them, The common potential V is given by this C1 V1 plus C2 V2 divided by C1 plus C2. So you can use this method to find out the common potential that is achieved after their combination. Okay. So this will give you the common potential. Once you obtain the common potential, so equivalent capacitance can be obtained by the parallel combination. That means the equivalent capacitance C would be equal to C1 plus C2. This will be the equivalent capacitance, right? And hence you can find out the new energy. So if you see the earlier energy, initial energy, we had 1 by 2 C1 V1 squared plus 1 by 2 C2 V2 squared. This was the initial energy of this system. Now, after they have been connected, you have the new energy. The new energy of the system is 1 by 2 of the capacitance, that is C1 plus C2 multiplied by V, and your V is given by this C1 V1 plus C2 V2 over C1 plus C2 whole square. This is your common potential. So you need to square them. Okay. So I'll give you just a direct formula for this. How it comes, you'll get 1 by 2 multiply C1 plus C2. Here you have C1 V1 plus C2 V2 whole square over C1 plus C2. You have a C1 plus C2 whole square. Now out of this whole square, one of them cancels, this one cancels, and you have this one as the energy. Let's see. Now your energy is 1 by 2. You have here, if you open the bracket, you get C1 squared V1 squared plus C2 squared V2 squared plus you'll get 2C1 V1 C2 V2. This is the energy divided by C1 plus C2. So this is the final energy. Now if I find the difference of the energy, so U2 minus U1, this is the difference of energy that I want. The initial energy that was there, sorry, U1 minus U2 I want. Final minus initial will give me the gain. Initial minus final will give me the loss. So U1 minus U2. U1 I had 1 by 2 C1 V1 squared plus 1 by 2 C2 V2 squared. V2 squared. And if you have to subtract this one. So from this you need to subtract this one. So take the LCM, solve it out, and see what is the answer that you are getting. If you take out the LCM here, everything, solve it out, obtain your answer. So you will get here, in the denominator, you'll be getting here C1 plus C2. Here you will get 2 also, here only. And this you will have here C1 squared, V1 squared, plus you will get C2 squared, V2 squared, plus you will get another C1, C2, V1 squared, plus you will get C1, C2, V2 squared, and minus of this also. So if you minus all this, you will see this cancels, this cancels, this cancels, this cancels, and you will be left with just this much of the energy. So what you will be left after this? You will be left after this with this expression. After solving it out, U1 minus U2, you will be left with the energies. You will be left here C1, C2, V1 squared. You can take out C1, C2 common, so you will get here V1 squared and plus V2 squared, and you will get here minus of 2 V1 V2. You will get here minus of 2 V1 V2. Here you have C1 plus C2. So you get this C1 C2 by 2 C1 plus C2 multiply with V1 minus V2 whole square. So now you get this. This is your loss of energy, and you get the loss of energy as a positive quantity. So you can directly remember this one to get the loss of energy. You can obtain the loss of energy directly. C1 C2 by C1 plus C2 multiply with V1 minus V2 whole square. So even if you take V1 minus V2 or V2 minus V1, it will be the same. So this is an important formula. You must remember this to obtain the loss of energy. In the previous question, if you remember, you can use this formula directly to obtain the loss of energy. V1, the initial potential was 100. V2, the final potential of the second one, that was 0. We know the C1 and C2, they are equal to each other. So you could have found like this also 1 by 2 C squared over 2C multiply with 100 minus 0. So this 1C cancels, and you will get your answer C by 4 multiply 100 square. 100 square is 10 to the power 4. So this is your loss of energy. The value of C was 900 microfarad, right? So put the value 900 microfarad here. See, you are getting the same thing. 900 over 4 multiply 10 to the power 4 multiply micro 10 to the power minus 6. You get your answer as 9 by 4 joule, which we had obtained previously. Okay. So by both of you, this was the answer for the previous one. And since it was given something multiply 10 to the power minus 2, so our answer here was 225. This would be the answer.
Okay, sir.
Okay, so this you are most appropriate to get this loss of energy. Okay, bye.
Thank you, sir.